objective and the eyepiece of compound microscope can be adjusted between 9.8 centimeter to 11.8 centimeter. Here basically I have shown you this is the objective lens of compound microscope, and here it is eyepiece, the lens which is normally close to the eyes. Here that is how you have to place your eyes to see the final image. So here is the objective lens and here is the eyepiece, and the separation between these two lenses is basically the length of the tube of the microscope. So here it is given that the length of the tube of the microscope can be adjusted between 9.8 centimeter to 11.8 centimeter, means this L is adjustable within the range of 9.8 centimeter to 11.8 centimeter. Okay, if the focal length of the objective and eyepiece are 1 centimeter and 6 centimeter respectively, so focal length of the objective f0 is 1 centimeter, so plus 1 centimeter, and focal length for the eyepiece is what, 6 plus 6 centimeter is the focal length of the eyepiece. If the final image is to be formed at 24 centimeter from eyepiece or eye, then magnification range is, so we have to find the range of the magnification of this compound microscope. Okay, we have to find the range of the magnification of this compound microscope when the length of the tube is varied from 9.8 centimeter to 11.8 centimeter. So to solve this problem, of course, we are going to use L as a unknown quantity, variable quantity, so that in the final result we may substitute the value of L, the 9.8 and L as well as 11.8 centimeter to get the final answers. We are not going to solve this twice to get both the values of the magnification. Anyway, for any length L here, how the compound microscope is going to work? What we do, we set one object at a certain distance from the objective. So U0 here is the distance of the object from the objective lens, and then its real image is formed. So here it is the real image formed by this objective lens. So distance of this image from the objective is V0. Alright, so as far as this objective lens is concerned, the magnification produced by this objective lens is what? V0 divided by U0. Alright, so this is M1, and the second magnification is produced by this eyepiece. So magnification of the eyepiece is basically M2 is equal to 1 plus D divided by F. Okay, it is 1 plus D by F, where D is the least distance for the clear vision, which is 24 centimeter in this case, because maximum possible magnification is achieved when the final image is at a distance of 24 or 25 centimeter from the eye. So that is the condition for the maximum magnification. So here the value of the D is 24, F eyepiece is 6. So what would be the magnification power of the eyepiece? It would be 1 plus D is 24 divided by F, F is 6, so it is 5. And the final magnification of the compound microscope is going to be what? M1 into M2. So M1 is V0 upon U0, that is something we have to find, and then we can multiply it with the M2, 5, which is independent of the length of this tube. Okay, anyway, so how to proceed? So we will start with the eyepiece only, because here we know that the final image distance has to be 24 centimeters. So for eyepiece, so let us first inquire that for what value of UE the value of image distance would be 24 centimeter in case of eyepiece. So let's apply the formula 1 upon F is equal to 1 upon V minus 1 upon U for the eyepiece. F is 6 centimeters, so 1 upon 6 is equal to 1 upon V. V is minus 24 centimeter, because here the object is placed, because the image formed by the objective lens serves the purpose of the object for the eyepiece, that we already know, and we can make the image of this image from eyepiece at 24 centimeter, 25 centimeter or at infinity. There are two extreme setting situations. The one is where the final image is formed at infinity, and the one which is the case when final image is formed at a least distance of the clear vision, which is 24 centimeter in this case, or usually it is 25 centimeter in normal situations. So 1 upon V, V is minus 24, minus 1 upon U, U is minus UE. We are using UE as the value of this distance. So here, what is the value of UE that we are going to get is 4.8 centimeter will be the UE. So the scope for V naught would be, what would be the value of the V naught? V naught would be the length minus UE, means length minus 4.8. Okay, this is the value of the V naught. So for this particular V naught, what should be U naught? Because for magnification we need V naught upon U naught. So let's apply the same formula of the length for object. So here it is for objective length. We have 1 upon F is equal to 1 upon V minus 1 upon U. So 1 upon F, F is plus 1, is equal to 1 upon V. For length, V is plus V naught. V naught is L minus 4.8 minus 1 upon U. U is minus U naught. Okay. So value of U naught can be calculated from here. So here 1 upon U naught is 1 minus 1 upon this. So it can be written as this. So 1 upon U naught. Let it be 1 upon U naught only, because for M1 we need V naught upon U naught. So we can multiply V naught with 1 upon U naught. So V naught is L minus 4.8 and multiplied with 1 upon U naught, which is L minus 5.8 divided by L minus 4.8. So we can see that M1 value is what? L minus 5.8. So when L is 9.8, in that case M1 will be 9.8 minus 5.8 equal to 4. Okay, when L is 9.8, M1 is 4, but when L is 11.8, in that case M1 would be 11.8 minus 5.8 equal to 6, and these two numbers are to be multiplied with the 5 also. So M1 is 4 up to 6. That means if we multiply M1 and M2, then the final magnification M is going to lie between the two values. What are those two values? The first value is 5 into 4. It is 20. It should be greater than 20. And the second value is 5 into 6, which is 30. So 20 to 30 will be the answer to this situation. Means for this compound microscope, we can change the length of the tube from 9.8 centimeter to 11.8 centimeter, but the condition is that the final image is to be formed at 24 centimeter from eye. So following that condition, we have solved for magnification. Option A would be the correct option to this question.